This is a demo of Boomi Companion, an AI-powered development assistant for the Boomi integration platform. In this video, we will observe a relatively complex EDI interface being generated from plain language using nothing more than a natural language prompt and a mapping specification document as inputs. Here we have Visual Studio Code with the integrated terminal. Claude Code is running directly in this terminal. The project folder contains a .-env file, which holds the Boomi platform credentials that Claude will use to authenticate and push components. You can also see the installed plugins, including the BC integration plugin from Boomi Companion, which gives Claude deep knowledge of the Boomi platform. This is the prompt we prepared. It describes the complete integration in plain English: the trading partner, the message standard, the mapping specification, the target system, and the error handling requirements. No code, no configuration files, just a natural language description of what we want built. We paste the prompt into the terminal and hit enter. Claude immediately begins working. First, it reads the core Boomi thinking documentation to understand the platform's architecture. Then it checks the environment, confirms the platform connection, and looks up any existing trading partner and folder structures to avoid duplicating components. Next, Claude creates the project folder on the Boomi platform, then works through each component in dependency order: profiles first, then trading partners, then the map, and finally the process itself. Each component is pushed to the platform immediately after creation, so the generated component ID can be used by the next dependent component. Along the way, Claude encounters and self-corrects several validation errors, fixing XML structure issues by reading the exact component documentation. The entire process, building, validating, pushing, and correcting, runs autonomously for around 24 minutes. What you are seeing here is the condensed view of those key moments. This is the mapping specification provided as an Excel file. As you can see, the field level mapping is not exhaustive. It is intentionally high level and ambiguous. For example, this row describes the delivery party from the NAD segment in EDIFACT and maps it to the partner information segment in the IDOC. And down here, the LIN segment carries the article number and line item, details that feed into the item segment of the IDOC. Let us now look at what was created on the Boomi platform. We navigate to the Claude Code folder and open the Orders subfolder. All components are here, organized exactly as the prompt specified. Opening the process, you can see the complete canvas, the trading partner, start shape configured for EDIF, ACT. Opening the sender trading partner, you can see the AS2 configuration. Scrolling down, notice that the sensitive fields, the AS2 identifier, the endpoint URL, and the GLN are marked as placeholders. These are intentionally externalized so they can be set per environment through Boomi's environment extensions without touching the component itself. Here is the SAPJCO connector. The connection and operation fields are empty. This is expected. The SAPJCO library needs to be installed on the runtime node before this can be configured. So Claude documented this clearly and left it for manual setup. Now the map. Claude generated this from the XSD profile and the mapping specification. The source is the EDIFA CT orders D96A profile. The target is the full ZEG1 orders IDOCXML profile, built from all 17 segments in the XSD, expanding the E1EDKA1 segment. You can see the instance identifier for partner function WE, which represents the delivery party. Scrolling down to the E1 EDP01 item segment, the line item number from LIN01 is mapped to POSEX, and the ordered quantity from QTY is mapped to MENGE. One interesting moment during this session, Claude initially generated the map without two required attributes on every mapping element, which caused the map to appear completely empty in the Boomi GUI. When this was pointed out, Claude traced the issue back to not having read the map component documentation completely before generating the XML. After fixing the map, Claude stored this lesson in its persistent memory. The next time a map is generated in this project, or any future session, Claude will read the map documentation in full before writing a single line and will not repeat this mistake.